In this video, we're going to go over how you can build an arm for your robot. And if you have the thumb drive for the VEX course, and this was discussed in an earlier video, but just go to the index here, and so if you click on reference here, and then you have RecBot building instructions, and open that up and scroll down to just about to the bottom there. You'll see here's a picture of the arm that we're going to build, except it's not going to have these pieces right here at the end to hold something. So we'll build, and it's not going to have the motor or the encoder, but we'll build pretty much most of what you see right there. So the first thing you want to do is organize all your parts, and you can see that you have a materials list here. So the first thing is the 832 by 1/4 inch long screws. So the VEX pretty much uses things in the English system. So 832, 8 is the size, it has to do with the size of the diameter. 632 is a smaller screw, for instance. 32 means 32 threads per inch, and then 1/4 inch is just how long it is. So you can see that you have 10 of these 832 by 1/4 inch long, and then you have 12 of the 832 by 5/8 long. You have 14 of these nuts, and you put the nut on so that this goes up against the part, and this little star here piece keeps the nut from loosening up. And then you should have 2 3-inch long shafts and shaft collars with set screws. You should have 4 of those. You should have either 10 of these 3mm plastic. These are 3D printed actually spacers, or they're just about the same width as a collar. So you may have 6 shaft collars without set screws. Set screw is, let's see, I think I had one. So this one still has the set screw in it, and you can see that's just a little screw, and you can tighten it up with an Allen wrench on the shaft, but it's very narrow, so it doesn't interfere with anything. We actually gave you 4 of the collars with these 832 1/4 inch screws, just so that you can the same size Allen wrench fits everything. In other words, you need a smaller Allen wrench for the collars, so we thought it'd be easier. Unfortunately, you can see how wide that head is on this screw, so it actually, you'll see when we're putting it together, in one case, it actually interferes with the bearing, so probably should have given you just the ones with the set screws. So those are the collars, and then you have the bearings are these black. They have 3 holes in them. Those are Delrin bearings. These are the standoffs right here. So they're threaded at either end. So those are 3-inch standoffs. You have 2 12-tooth gears, and then you have 2 60-tooth gears. And the C channel, you should have 3 pieces that VEX calls these 1 by 2 by 1s, and there should be 15 holes. So you can see 1, 2, 3, 4, 5, plus 10, another 5 is 10, and 5 is 15. You should have 3 like that, and then you have one like this with 10 holes. Now you may have something that looks like this. It's like an L shape, and as indicated down here in the text, you may have, these are called chassis rails, so you can still use them. See, they're pretty much the same, except they don't have this end. They're missing a side. So you can use, to build this arm, we can use either C channel or these chassis rails. So, but you should have at least one. Make sure that every team has at least one of these 15-hole C channels, because this is going to be the arm. We're going to put a gear, mount a gear on either side of this. So you want to make sure that each team has at least one of these C channels. Okay, I think earlier I said that the 3mm spacers were the same thickness as the collar. So what I meant to say was that 2 of the 3mm 3D printed spacers is about the same as the collar. And we wanted to send you enough spacers. Actually, normally you don't want to use a collar as a spacer, but because we're starting school and we didn't have enough spacers to send along. And the other thing, I think I said that you want to have a 10-hole. You can see this piece I have right here actually has 9 on the side. It was cut, and that still will be okay. It's the distance from here to here. I'll show you how to do that when we get to that. But anyways, excuse me. So if you have all your parts, the first thing we're going to do is build the arm. So let me just move some of this stuff out of the way. Okay, so we're going to put a gear on either side, and you can see that if we were just tried to bolt this, there's 2 holes here. You want to put a bolt through this hole and into this end hole. But you can see that if because of the width of the axle here, right, with a square, and this we want to be a little bit wider. The wider that is, then the force being exerted on the axle will be reduced, right? So in other words, in this particular case, we're going to bolt the gear right to the arm. But if you have a wider hub here, then for a given amount of torque and a given force on those corners, it'll be reduced because there's more area to spread it out over. But the problem is that this is going to be off. In other words, if we put a bolt through now, then we'll end up, if we try to tighten up the bolt, we're going to warp the gear. So that's why what we want to do is we put a bolt through that hole, and then take one of the collars without the set screws. Okay, and it might be a little hard. You might have to, you might have a little trouble pushing that on. Just push that on, and now you can see this is going to be offset, so that when we tighten it up, it's not going to push on the hub and warp the gear. So you can just go ahead and put that on there. Okay, and then you'll do the same thing on the other side. Take a collar without a set screw, and you can get this ready. Put that through, and then come through on that side. Okay, and don't tighten them up too much. Just finger tight for now. And then you'll do exactly the same thing on the other side. All right, my fingers will cooperate here. Okay, so you want to do the same thing on the other side. Okay, and then just put a screw on the other side and a collar. Okay, and while that's loose, we're going to put the axle through. Okay, So you can see since it's a little bit loose, you might have to just jiggle it a little bit and get the axle through so it's about the same distance through on both sides. And then you can take your Allen wrench and just snug up the the the, the 4 screws. All right, you can just hold the nut with your finger and just snug that up a little bit. You know, it doesn't have to be super tight. So now you have the arm, okay, and you have 2 gears on spacers attached to the arm with an axle. All right, so we have the arm with the spacers, and I think earlier in the video I said that by having a wider hub, it reduced the force on the corners. It doesn't reduce the force. The force is spread out over a larger area, so it reduces the stress. So I just wanted to be clear that it's making the hub wider doesn't reduce the torque, but it does reduce the stress on the material. So the next thing we want to do is prepare the side rails. So now you want to take, if you have another C channel, the 5-hole C channel, you can use that, or if you have an angle, you can use that. And what we're going to do is put one of the 1/4-inch screws through the end here, and just take one of the standoffs and just screw that on. Okay, and then we want to, if that's hole number 1, right, so we want to go 1, 2, 3, 4, 5, 6, 7. So hole number 7, put a 1/4-inch screw in there, and put another standoff on that. Okay, so now there should be 5 holes. 1, 2, 3, 4, 5. 5 holes in between, empty holes in between these two. And then, so, you know, if you had a piece like this, right, then you would just, you know, do the same thing, except the side with a single row of holes, you just do it like that. So you won't have this lip on this side for the C channel, but it'll still work. Okay, and then you want to do the other side with to be the mirror image. So we want the other side to be the mirror image. So put a screw there, and then put the standoff on here. Okay, and then same thing. Right, so again, you're going to have 1, 2, 3, 4, 5 empty holes. All right, so now we have 2 pieces like that. And the next thing we want to do is put the bearings on. So if I put this piece like this, okay, then what you're going to want to do is have 4 empty holes in the middle. So 1, 2, 3, 4, and then take your bearing, and that goes like that. Okay, so we have 4 empty holes, 1, 2, 3, 4, and then we'll put bolts, we'll put the screws through on the 2 ends. Okay, so we'll leave the middle hole empty. Like that. And then leave us 1 space and put the other bearing, but and this time we're going to leave this end empty, and we'll put screws in the other 2 holes. Okay, All right, so as I said, we'll put a screw in the middle one this time. Okay, and then you can just go ahead and snug those up a little bit. All right, and so now we have the mirror side here. And so we're going to want to do the same thing. 1, 2, 3, 4 empty holes, and then put a bearing right there. In this first one, we put the bolts in the 2 end holes and leave the center hole empty. Right, again, 1, 2, 3, 4 holes empty, and then okay, and then take the other bearing, leave 1 hole space, and this time we'll put a bolt through the end. But the second screw we're going to put through the center hole, and leave this hole empty. And then we can just snug up those 4 holes, those 4 screws. Okay, so this is, you can see what we have at this point. All right, so we have the 2 side rails now, and when this mounts on the robot, this back section is actually going to be over your cortex, the microcontroller in the back. So if you have angles, if you have rails rather than these C channels, then you'll have to put your brace underneath. And the reason that's undesirable is because it's going to be closer to the cortex. But since we have C channels here on this example that I'm doing, then we're going to put the rail on top. Okay, and so the bearings actually face each other. So in this hole out here, I'm going to put a screw that comes through this, and then put a nut on this. And this time we want to have 6 holes. So depending on if you have, like mine was cut, and it's actually, 9 holes, 8 holes across here. So you want to have 6 empty holes. Now notice that all the VEX parts, all these holes are 1/2 inch apart. And that makes it easy to select different gear ratios that will work into bolt things together. And then this middle row is offset. So in other words, from here to here is a 1/2 inch. From here to here this way is a 1/4 inch. So you have a row that's offset. The same thing on this one right here. They're a 1/2 inch apart, but then this middle row is offset a 1/4 inch. So what we want is, again, you can see how I have this. I have the columns down here. If you have a chassis rail, you're going to have to put this part on the bottom because you don't have the top to screw into. Okay, and then you want to have 6 empty holes, and put this together. All right, so you can see that I have 1, 2, 3, 4, 5, 6 empty holes. Okay, so we get that in. So we're going to tighten that up a little bit more, and what you can do is you can come through the bottom hole with the Allen wrench so you can get at the head. And you want to tighten that up a little bit because you want these to be at 90 degrees to each other approximately. And just again, hold the nut with your finger and tighten this up a little bit. Okay, so we have that like that. And now what we're going to do is take our arm, and I'm going to put this in with the C channel up. These things are facing up here, and put the two collars with the actual set screws. But you can see this is what I was talking about before. I'm going to leave those set screws loose because the heads of the set screws are going to would actually interfere, right? If I turn this over, whoops. Okay, so you can see that these set screw heads would actually, I don't know if you can see that, they would actually hit the bearing. So I'll just leave them loose for now. But anyways, get this so that it's lined up square, and then just snug up your screws a little bit more, just to kind of hold that together. So we're almost done here. Okay, so now the last step is we have our last axle, and we're going to run the axle through and then put a spacer. Well, actually, I'm sorry, this one we want to, I'm sorry, right, so we'll have a spacer and then a gear. Okay, and then we'll put a collar with a set screw, put a collar with a set screw through, and then a second collar with a set screw, and these are going to hold everything in place. Okay, and then we put another gear, right, and get the gears, while you have a little bit of play there, get the gears so the teeth match up there, and then we put our last collar for the spacer. And again, if you have the red spacers, you can be using the red spacers on the ends. Whoops. So just get that through there, and then push that into again, make sure that you space these out a little bit and push the axle in place, and just push it through so it's the same. Right, it's just you should be able to feel the ends with your fingers there, just about there. And now what you want to do is push these two collars, like hold the axle in place and push these two collars out like this. So you can see how I held the axle in place and pushed those collars out. And now this collar is going to hold this gear up against this other spacer here. So just tighten that up against a flat section. And then this one is going to hold the other side. Okay, so with these two collars locked in place, then that axle can't go anywhere. And so now you can see that we have, let's see if I can get, right, so you can see that this now is working. And if you measure this, if these holes you can see are 3 inches apart, and then across this direction like this, they're 3.5. So you should be able to take this, if you look at the base spot, this should be able to fit on the base spot now. With this section is going to be out over the microcontroller, and this section will be hanging off the end of the robot. And then you could see you could add some kind of other metal here if you were going to carry a ball or something like that. And then if we had a motor, all we would have to do, so if we had a motor, all we would have to do is use a longer axle right here, and you can see here's the motor, and then these screws, you would use motor screws, and those would go into here, and the axle would go right into this section right there. And then if we had a potentiometer, now the potentiometer, if you look at on the VEX course, potentiometer is usually maximum you want to turn those is like around 210 degrees. So the small gear is going to turn a lot, right? In other words, if this arm, maybe it moves 180 degrees, but you have a 5-to-1 ratio, so the small gears are going to rotate 5 times that. So you can't put the potentiometer on the small gear, but you could, if you had extended this axle right here, then you could mount this potentiometer right there and use that. And so anyways, this arm, you should be able to, you should have 4 screws left, the 4 1/4-inch screws, and you should be able to mount this on your base spot now. And I just want to show you, here's a robot with a different kind of arm, but you can see here's the motor mounted to drive the small gear pinion, and then here's the potentiometer, right? Here's a potentiometer that's has the axle extended from the large gear because it doesn't turn more than like 180 degrees. So at any rate, that gives you a little bit idea of how to use VEX parts. As I said, most of the stuff is in English. The holes are all offset a 1/2 inch. Different rows are offset by a 1/4 of an inch, but it makes it fairly easy to put things together. So I hope this is helpful, and hope you have a great day.